Okay. The next presentation is about the brick-to-brick case. What we tried to do within HISER is there is a lot of documentation about recycling of concrete aggregates in new concrete. And this, if this is taken up more and more by the market, this would also mean that you have another fraction which contains less and less concrete, which is a more ceramic fraction. The goal here, at the moment you can see the Flemish production of bricks is around 3.5 million tons per year. That's masonry products, so that's also tiles and so on. And the amount of mixed aggregates in Flanders, which is about 50% of that, is masonry waste, is 4.3 million tons. The amount of masonry aggregates is a very small fraction, is 0.3 million tons. This is because the masonry aggregates are considered as low-grade mixed aggregates. The less concrete in the aggregates at the moment, the less value. You can also see that on the price of these aggregates. Further on, masonry aggregates means there is more than 60 mass% of masonry, which means that this fraction can still contain up to 40 mass% of concrete, for instance. So this is our goal. The goal is to have this masonry fraction, make a sand fraction out of them, and use in the production of new bricks. Together with Dumoulin bricks, we did this. And our goal, we want to replace 10% in this material. Why 10%? Because that's the maximum amount that is currently used as a temper agent. This is the opening substance that's the more coarse-grained fraction inside the brick that's used to prevent the drying cracks in the drying procedure of the unfired bricks. So it is the maximum amount. Since we will use an inert waste fraction, we will not replace clay, for instance. We will also not replace materials that are used that have an energetic value during the firing process. And we will also not replace other waste materials that are currently used in the production. Then we are left with these 10%. We started with making these materials in the lab, and from these tests, we have seen that there is no quality decrease if we use, instead of pure masonry fraction, we use material that has also gypsum or mortar there. No quality decrease in the amounts that are like a logic amount for these kind of materials. But of course, if you have a lot of gypsum contamination, you will have problems with the flue gases because you have sulfuric SO3 and so on. And of course, you can have efflorescence if you have a significant amount of gypsum, but the aggregates at the moment, masonry aggregates already contain a maximum amount of 1% of gypsum. Concrete, however, if we have concrete in our aggregates, we will most of the times have limestone there, and this limestone fraction will not create a homogeneously divided amount of calcium oxide inside the fired bricks. If these bricks are coming into contact with water, we get calcium hydroxide, and we get pop-outs or cracks. So the presence of lime, the distribution is crucial. If we have finely divided lime inside the bricks, it's okay. If we have at one spot a big particle of calcium oxide, we will have cracks or pop-outs. What we did is we used three samples in the Dumoulin factory. So for the industrial production of our bricks, we used a reference where we used porphyry sand as a temper agent, which is normally used by Dumoulin bricks. We used mixture 1, which contained production waste. So this is pure brick. And we used a mixture 2, which contains 10% of selectively demolished masonry waste. So this means we have brick walls, we demolish them, we have bricks and the mortar that's used to build these walls, and that's the material we start from. So we are not going to sort further, because we have seen in the lab also that this is not necessary, that we can implement the mortar that's available in this fraction. You see on the left side the production waste, on the right side the selectively demolished masonry fraction. This is where we selectively demolished the masonry waste. And then we mill this fraction into a sand fraction of 0 to 2 millimeters. Since that's also the size fraction, the size distribution of the porphyry sand that we are going to replace. And next slide takes a while. Yeah, there it is. It's actually a video, but you can let it like that. Yeah, so the video doesn't work. In the previous picture, it's not that visible, but this is the raw materials that enter, and on the left side, it's orange material. That's because that's the masonry fraction that we used, and this happens with inside the factory of Dumoulin. All these raw materials are heavily mixed to each other, and this also creates, if we have mortar here that's coming in 0 to 2 millimeters, when after this process the size fraction is quite smaller. And then we make bricks, which look like this before firing and look like, yeah, turn orange in the next picture after firing these bricks. Okay, there they are. The one on top is one with a reference sample, so 10% of porphyry sand. The one here close by is the one with 10% of selectively demolished masonry fraction. And if we look at quality parameters, we see that our bricks that we produce with the masonry fraction actually have a slightly higher compressive strength compared with the reference sample. This is probably the case because of our size distribution of our masonry waste that's different in comparison to the porphyry sand. We have a slightly higher water absorption, which is logic because our masonry fraction is more porous than the porphyry sand. But we have also done 3 star cycles to see if this higher water absorption is a problem in long term, and we see no visible damage. We've done the same test as we normally do with this kind of bricks. And also the soluble salt amount is lower than the standards. What we then were looking for, because as I said, we used selectively demolished samples. It's perfectly possible to create these samples on a demolition work. So we looked into commercially available sand fractions in the hope we could find something that was commercially available. But as I said, masonry aggregates are at the moment considered to be low-grade mixed aggregates. So none of these crushing installations have the incentive at the moment to produce a fraction that contains almost no concrete, because that would be in the current market a very low value fraction. So even if you see in these very low percentages of masonry aggregates that are produced, they still contain a lot of concrete, and it's not feasible to use them in our samples. Conclusions: we replace 10 volume % of the raw material mixture in bricks with the masonry fraction, so with a recycled material, and our newly produced bricks meet all the required standards. And so the presence of mortar is not a problem in this case, which means we don't need extra steps in between. So the main conclusion is the sand fraction of a selectively demolished masonry fraction can easily be recycled in new bricks. If there are any questions? Yes?
Is it implemented in practice now? Or is there an economic argument not to do it?
Well, so we are still looking into this. So at the moment, this would mean that our Dumoulin bricks has to build their own crushing installation, where they would, there are two options there. They crush everything into a sand fraction, or they crush the material. They have a sand fraction which they use themselves, and they put the aggregate fraction on the market. The other possibility is that we search for a crushing installation close by Dumoulin, but then we have the same problem. We can use the sand fraction if the material that's produced there is a selectively demolished, comes from a selectively demolished aggregate fraction. But that means that the lower price this crushing installation will get for the aggregates has to be compensated with a higher price that Dumoulin is prepared to pay for the sand fraction in comparison to other crushing sands. So we're still looking into this. Of course, the more and more there is a push towards high purity gray fractions, the less and less concrete we will find in the other fractions. No other questions?